Good morning, Nishtha.
My name is Nishtha. I am a proud student of 11C in Sunrise Foundation School. And today I am here to speak about the discovery of electrons. The discovery of electrons was done by Michael Faraday. In 1830s, Michael Faraday showed that when electricity is passed through an electrolytic solution, then the chemical reactions occur at the electrodes, which leads to a deposition or liberation of some matter on the electrodes. This results in the particulate nature of electricity. Here I use the words electrodes and particulate nature of electricity. Electrodes are the solid electric conductor which conducts electricity, and these are especially the magnets. Particulate nature means the particle nature. As here we talked about the particulate nature of electricity, so it shows the particle nature of electricity. Now, in mid-1850s, many scientists performed experiments, especially Faraday. They began to study the electrical discharge in partially evaporated tubes, and these tubes were known as cathode ray discharge tubes. A cathode ray discharge tube is made up of glass, which contain two thin pieces of metal which are acting as electrodes and are sealed into it. Now here I also use two other words that are electrical discharge and partially evaporated tubes. Now, electrical discharge is the process of flow of charge, and partially evaporated tubes are the tubes from which air is pumped out. Now, as they performed this experiment, they showed that the electrons move from the negative to the positive terminal of the battery. This electrical discharge could be observed at certain conditions, and the conditions were that it should be at a very low pressure and at very high voltage. So when high voltage is applied, the electrical discharge takes place. But there is one condition to be seen with the naked eyes of human beings, that the anode should be perforated, which means that a hole is made in the anode, and behind the anode the fluorescent material, that is zinc sulfide, is applied. So when the cathode rays pass through the anode and strike this layer, then these will be visible to the human eyes, and one could see the electrical discharge. Now there are some results of this experiment. That is, the rays move from cathode towards the anode, and that's why they are known as the cathode rays. The second result is that as this electrical discharge could not be visible with the naked eyes of human beings, so a material of fluorescent is zinc sulfide is applied, and then it can be only seen with the naked eyes of human beings. The real life example of this is the television pictures. Now the third one is that without any magnetic or electric field, these cathode rays moves only in the straight line. But when the magnetic or electrical field is supplied, then these rays move from the negative to the positive terminal, and that's why they are known as cathode rays. They show the nature such as the negative charges, that are electrons. That is why electrons are considered the constituent of all atoms. These cathode rays do not depend on the nature of the gas that is present inside the tube, and does not also depend on the material of electrodes. So, the conclusion of this experiment is that electrons are the constituent of all atoms. So, this was all from my side. I hope you understood it. Thank you and have a nice day.